Welcome to another deep dive. Today we're going to be talking about something that's literally all around us all the time. Earth's atmosphere. We're breathing it in every second.
Absolutely.
We don't really think about it very much, but it's absolutely crucial to life on Earth.
It is.
Today we're using a presentation titled The Atmosphere and Its Properties
Okay.
as our guide.
Mm-hmm.
And we're going to get into some pretty amazing stuff about the atmosphere.
Yeah.
Now, you can use this information to impress your friends later.
Sounds good.
Sound really smart.
I like it.
So I guess to start off, what exactly is the atmosphere? I mean, it's invisible.
Right. So the atmosphere is basically a layer of gases that surrounds the Earth.
Okay.
And what's really cool is that these gases are held in place by Earth's gravity.
Ah.
So it's not just empty space up there. It's this invisible shield that protects us.
A shield. That's kind of like a force field protecting us from outer space.
Exactly. It's like a delicate protective bubble surrounding our planet.
Wow. So it's not just oxygen up there. I mean, we need oxygen to breathe.
Yeah, that's what everybody thinks.
Right.
But it's so much more than just oxygen.
So what's the breakdown then?
Okay, so get this. 78% of the atmosphere is actually nitrogen.
Wow, really? Nitrogen?
And then about 21% is oxygen.
Okay.
And then the remaining 1% is made up of a bunch of other gases,
Like what?
like argon,
All
carbon dioxide, a little bit of water vapor,
Okay.
and then trace amounts of other things.
So every time I take a breath, I'm mostly breathing in nitrogen.
You got it.
Yeah.
Wow, I never knew that.
Yeah, most people don't.
But all these gases, what do they actually do for us?
Right, well, they do a lot.
Okay.
First off, the obvious one, right? Provides the oxygen we need to breathe.
Okay.
But it also acts as a giant shield, protecting us from harmful solar radiation from the sun.
Oh, so it's like a giant sunscreen.
Pretty much. Keeps us from getting fried.
Huh.
And check this out. It also burns up most meteors
Whoa.
before they can reach the Earth's surface. It's like our own personal defense system
It is.
against space rocks.
That's a good way to put it.
So cool.
Yeah, and that's not all.
Okay.
It also traps heat, right? Which keeps the planet warm enough to support life. Which...
Yeah, the greenhouse effect.
Exactly. The greenhouse effect.
But the atmosphere does even more.
Oh, yeah.
Oh.
Maybe most importantly, it creates the atmospheric pressure that allows for liquid water to exist.
Wow, so no atmospheric pressure.
Yeah.
No oceans, no lakes, no rivers.
Exactly.
Wow, so we need that pressure to basically make life as we know it possible.
It's essential.
So we've got this layer of gas surrounding our planet doing all this amazing stuff.
It's pretty incredible.
But you said it's not just one big homogeneous blob of gas.
No.
Like what, it's layered or something?
Yeah, it's actually divided into distinct layers.
Oh, wow.
Each with its own unique characteristics and functions.
Like a layer cake.
Yeah, like a giant layer cake surrounding the Earth.
I love layer cake.
Me too.
So how many layers are we talking? And like, what are they called?
Okay, so starting from the ground up, we have the troposphere,
Okay.
the stratosphere,
Okay.
the mesosphere.
The meso what?
Mesosphere, yeah.
Okay.
The thermosphere,
Okay.
and then way out there, the exosphere.
Wow, so that's 5 layers.
5 distinct layers.
Okay, so which layer do we live in?
We live in the troposphere,
The troposphere.
okay, which is the layer closest to the Earth's surface.
So, like, how high up does that go?
It extends upwards to about 10 kilometers.
10 kilometers. Okay.
Which is roughly about 6 miles.
Okay. And what happens in the troposphere? Besides, us living in it.
Well, this is where all the weather happens.
Okay.
Rain, snow, wind, clouds, all that good stuff.
So, like, when I check the weather app,
Yeah.
that's telling me what's happening in the troposphere.
Exactly.
Yeah.
And it's also where most of the atmospheric water vapor is found,
Okay.
which is why we get all that precipitation.
Okay, that makes sense.
Another interesting thing about the troposphere is that the temperature decreases as you go higher.
Oh, yeah, like, that's why it's colder on top of a mountain
Exactly.
than it is at the bottom.
Yeah, the higher you go in the troposphere, the colder it gets.
Okay, that makes sense.
So above the troposphere, we have the stratosphere,
The stratosphere, okay.
which extends from about 10 to 50 kilometers above the Earth.
Okay.
And this layer is home to the ozone layer,
Ooh, the ozone layer.
which is incredibly important
Why is that?
because it absorbs most of the sun's harmful ultraviolet radiation.
Oh, okay.
So it's like a giant shield protecting all life on Earth from getting fried.
That's pretty important.
It is absolutely essential for life as we know it.
Yeah, but didn't we, like, mess up the ozone layer?
Yeah, so back in the day,
Yeah.
we were using a lot of these man-made chemicals,
Okay.
particularly chlorofluorocarbons, or CFCs.
Like, what kind of things were those in?
Those were in refrigerators,
Okay.
aerosol sprays, things like that. And what happened was these CFCs, when they got released into the atmosphere, they actually started to break down ozone molecules.
Oh, no.
Yeah, and this led to like a thinning of the ozone layer, which is what we call ozone depletion.
And so then more UV radiation could get through.
Exactly, which meant more harmful radiation reaching the surface of the Earth.
And that's bad for...
And that's bad for everything.
For people.
For people, plants, animals, the whole ecosystem.
So what do we do about that?
Well, once scientists figured out that CFCs were causing this problem, there was a huge global effort to phase them out.
Okay.
And this led to something called the Montreal Protocol, which was an international treaty signed in 1987 that basically banned the production of CFCs.
Wow. And did that help?
It did. It's actually been incredibly successful.
Oh, good.
The ozone layer is slowly but surely recovering.
So it's on the mend.
Yeah, it's definitely on the mend.
That's good to hear.
It's a really good example of how international cooperation can actually make a difference in protecting our planet.
Okay, so we talked about the troposphere, the stratosphere. What's next?
Next up is the mesosphere.
The mesosphere.
Which is often called the middle layer.
Okay.
Because it's, right in between the stratosphere and the thermosphere.
Okay, how high up is that?
So the mesosphere extends from about 50 to 80 kilometers above the Earth.
Okay, and what's so special about this middle layer?
Well, for one thing, it's the coldest layer of the atmosphere.
Oh, really?
Yeah. Temperatures can drop down to minus 90 degrees Celsius.
Brr, that's cold.
That is seriously cold. But it also plays a very important role in protecting us from meteors.
Oh, yeah. You mentioned that earlier.
Yeah. So as meteors enter the Earth's atmosphere, they encounter increasing air resistance in the mesosphere. And this friction causes them to heat up and burn up.
So that's what a shooting star is.
Exactly.
A meteor burning up in the mesosphere.
It's like a natural fireworks show.
It's amazing how much is going on up there.
It really is.
That we don't even realize.
So much happening above our heads.
So we've got the troposphere, the stratosphere, and the mesosphere. What comes after that?
Above the mesosphere, we have the thermosphere.
The thermosphere.
And this layer extends from about 80 to 500 kilometers above the Earth.
Okay.
And here's where things get a little paradoxical.
Okay, how so?
The thermosphere is actually the hottest layer of the atmosphere.
Really? Hotter than the stratosphere?
Yeah, it can reach temperatures of thousands of degrees Celsius.
Wow, but wait a minute. I thought space was cold.
Yeah, that's the paradox.
So how can the thermosphere be so hot if space is cold?
Well, it all comes down to the concept of heat transfer.
Okay, I'm listening.
While the temperature in the thermosphere is incredibly high, the density of air molecules is extremely low.
Okay.
So even though the air molecules are moving very fast, indicating high temperature, there are so few of them that they don't transfer much heat to an object like a satellite.
So it's like the thermosphere is a really hot oven, but with hardly any air inside.
That's a good way to visualize it.
So you wouldn't actually feel that heat.
Exactly. It's a matter of how much heat can be transferred.
That's pretty mind-blowing. So the thermosphere is super hot, but not in the way we typically think about heat.
Exactly.
It's all about the density of the molecules.
Right.
Wow, this is fascinating. What else happens in the thermosphere?
Well, the thermosphere is also home to the ionosphere.
The ionosphere.
Yes, which is a layer that's electrically charged.
Okay.
Meaning it contains ions and free electrons.
I vaguely remember learning about this in school, but I don't really get it. What's so special about the ionosphere?
Okay, so the ionosphere has this amazing ability to reflect radio waves.
Really?
Yeah. And this is actually what allows for long-distance radio communication.
So before satellites.
Exactly.
That's how radio signals were bounced around the globe.
You got it.
Wow. I had no idea.
Pretty cool, huh?
That's amazing. It's like a giant mirror in the sky for radio waves.
Exactly.
Wow, the thermosphere is full of surprises. It is. Super hot, but not really, and it reflects radio waves. What's next?
Well, beyond the thermosphere,
we
reach the final frontier of Earth's atmosphere.
Okay, hit me with it.
The exosphere.
The exosphere, okay.
And this is where things get really interesting.
In what way?
This is the outermost layer of the atmosphere.
Okay.
And it's where Earth's atmosphere gradually fades into the vacuum of space.
Wow, it's got to be pretty far out there.
It is. And it's a really unique environment.
Like what? What's it like out there?
It's incredibly vast and incredibly still.
Okay.
The air molecules are so spread out that they rarely collide with each other.
Oh, wow.
And some of these molecules actually escape Earth's gravity and just drift off into space.
So it's like the final goodbye between Earth and its atmosphere.
Yeah, it's a beautiful thought, isn't it?
Yeah, it's kind of poetic.
It is.
Like where our planet ends and the vastness of space begins.
Exactly.
Wow, we've gone from the ground level up through all these different layers, each with its own crazy characteristics.
It's pretty amazing.
But all of them together make this amazing shield that protects us and allows life to flourish.
It's a delicate balance.
Yeah.
But it's a beautiful one.
It is. This has been an incredible deep dive into the atmosphere so far.
Yeah.
We've learned so much.
We have.
I'm starting to see the atmosphere in a whole new light.
That's great.
But there's still so much more to explore.
Oh, yeah. There's a lot more to talk about.
We need to take a break.
Okay.
Let all this information sink in.
Sounds good.
But when we come back, we'll delve even deeper into the crucial role the atmosphere plays in regulating Earth's temperature.
Okay.
And how human activities are impacting this delicate balance.
Looking forward to it. So we're moving on from the stratosphere now.
Okay.
Up into the mesosphere.
Mesosphere, that's the one where it gets really cold, right?
We got it.
Like crazy cold.
It is the coldest layer of the atmosphere.
It's crazy how the atmosphere can be so different from layer to layer.
It really is.
But even though it's so cold, the mesosphere still does some pretty important stuff.
Oh, absolutely.
Like protecting us from meteors.
Exactly.
You mentioned that earlier.
Yeah, so basically those meteors are hurtling towards Earth at super high speeds.
Okay.
And when they hit the mesosphere, they run into a lot of air resistance.
Okay.
And that friction causes them to heat up.
Yeah.
Like a lot.
And that's what causes them to burn up.
Exactly. Most meteors burn up completely before they can even reach the ground.
So every time I see a shooting star, that's actually a meteor burning up in the mesosphere.
You got it.
Wow, that's so cool.
It's like nature's own fireworks display.
Yeah, it is. And it's a good reminder that our atmosphere is constantly protecting us.
All the time?
From all this stuff flying around in space.
Yeah, we really do take it for granted.
We do. So, okay, we've talked about the troposphere, the stratosphere, the mesosphere. What's next?
Next up, we're heading to the thermosphere.
The thermosphere, okay.
Which is, well, it's a bit of a paradox.
No, how so?
Because it's the hottest layer of the atmosphere.
Wait, really? Hotter than the stratosphere with the ozone layer?
Yeah, the thermosphere can reach temperatures of thousands of degrees Celsius.
Thousands? But how is that possible? Isn't space supposed to be cold?
That's where the paradox comes in.
Okay, I'm intrigued. Explain this to me.
It all comes down to the difference between temperature and heat.
Okay, I'm listening.
Temperature is really just a measure of how fast the molecules in a substance are moving.
Okay.
But heat is about the transfer of thermal energy.
Okay, so temperature is like how much the molecules are jiggling around, and heat is like actually feeling that warmth.
Exactly. So in the thermosphere, even though the temperature is super high, the air density is incredibly low. Meaning there are very few molecules to bump into and transfer heat.
Oh, okay. So even though the molecules are moving really fast, because there are so few of them, they don't transfer much heat to anything.
Exactly. It's like, imagine you're in a sauna.
Okay.
It's really hot, right?
Yeah.
But if the air is really dry, you won't feel as hot.
Right, because there's not much moisture to transfer the heat.
Exactly.
Okay, that makes sense. So the thermosphere is kind of like a dry sauna.
Pretty much.
Super high temperature, but not much heat transfer.
You got it.
Wow, that is crazy. The atmosphere never ceases to amaze me.
It's full of surprises.
So we've got this super hot, but not really hot layer. What else is going on in the thermosphere?
Well, this is also where we find the ionosphere.
The ionosphere. Oh, yeah, I remember hearing about that.
Right. So the ionosphere is basically a layer of the atmosphere that's electrically charged.
Okay.
Meaning it's full of ions and free electrons.
Okay, so like static electricity.
Kind of. And what's cool about the ionosphere
Yeah.
is that it can reflect radio waves.
What? Really?
Yeah. And this was super important before we had satellites.
Oh, I see. That's how radio signals could travel long distances.
Exactly. They would bounce off the ionosphere and travel around the globe.
Wow, that's pretty ingenious.
Yeah.
So the ionosphere is like a giant mirror in the sky for radio waves.
A perfect analogy.
That's amazing. So the thermosphere is super hot, but not really. NEDs can reflect radio waves.
It's a pretty versatile layer.
It is. What's next? What comes after the thermosphere?
Well, after the thermosphere, we come to the final layer.
Okay.
The exosphere.
The exosphere. Okay, tell me about it.
This is the outermost layer of the atmosphere.
Okay.
And it's where Earth's atmosphere gradually fades into the vacuum of space.
Wow, so it's like the boundary between our planet and outer space.
Exactly. It's a really fascinating and kind of mysterious region.
Mysterious in what way?
Well, it's so far out there that it's incredibly difficult to study.
Oh, right.
But we do know that it's incredibly vast.
Yeah.
And the air molecules are so spread out
Yeah.
that they rarely even collide with each other.
Oh, wow.
And some of these molecules, they actually escape Earth's gravity altogether. Yeah, and they just drift off into space.
Wow. So it's like the final farewell between Earth and its atmosphere.
It is. It's kind of a poetic thought.
Yeah, it's like where our planet ends and the vastness of space begins.
Exactly.
So we've traveled all the way from the troposphere, where we live, through the stratosphere, the mesosphere, the thermosphere,
all the way to the exosphere.
and finally to the exosphere, where Earth's atmosphere gives way to the vastness of space.
It's been quite a journey.
It has. And I've learned so much. I never realized how complex and dynamic our atmosphere is.
It's a pretty incredible system.
It is. But it's also facing some serious challenges, right?
That's right.
We can't forget about that.
But
Like ozone depletion.
yes.
And especially climate change.
Absolutely.
Those are huge issues that we need to address.
Yeah, they're both linked to the atmosphere.
Right. And they're both caused by human activity.
Unfortunately, yes.
So I guess the question is, what can we do about it?
Well, that's a big question.
It is.
And it's a complicated one.
But it's a question we need to answer.
It is.
The future of our planet depends on it.
It does.
So we've talked a lot about the atmosphere.
Oh, yeah.
All the different layers, all the amazing things it does for us.
It's pretty incredible.
But we've also touched on some of the not so good things.
Right.
Like climate change.
Yeah.
It's a big problem. And I think a lot of people feel kind of helpless.
I understand that.
Like, what can one person really do?
Yeah, it can feel overwhelming.
But you're saying that our individual actions do make a difference.
I absolutely do.
So, like, what are some things that people can do in their everyday lives to help?
Well, one of the biggest things is reducing our reliance on fossil fuels.
Okay.
So that means driving less,
Okay.
using public transportation more,
Okay.
walking, biking, things like that.
Okay.
And also making sure our homes are energy efficient.
Right. Like using energy-saving appliances and light bulbs.
Exactly.
What about things like solar panels and wind power?
Those are fantastic.
Are those realistic options for most people?
They're becoming more and more accessible.
Okay.
Good, more affordable all the time.
That's good to hear.
So yeah, definitely look into those.
Okay, what about recycling?
Recycling is huge.
Does that really make a difference?
It makes a huge difference.
Okay, good.
It helps reduce waste,
Okay.
which in turn reduces greenhouse gas emissions.
So every little bit helps?
Every little bit counts.
It's kind of empowering to know
It is.
that we're not just bystanders.
They're not.
We can actually do things to help.
Absolutely.
So, okay, we've talked about reducing fossil fuels, using renewable energy, recycling. Is there anything else?
Well, another big thing is just being mindful of our consumption habits.
Okay.
You know, reducing waste in general.
Okay.
Choosing products with less packaging. Things like that.
So being more conscious consumers?
Exactly.
Okay, I can do that.
It all adds up.
It does.
Yeah.
This whole deep dive has really been eye-opening.
Good. I'm glad to hear that.
I used to think of the atmosphere as just like the air.
Yeah.
You know, something that's just there.
Right.
But now I see it as this incredibly complex and dynamic system.
It is.
That's essential for life on Earth.
Absolutely.
And it's made me realize how important it is to protect it.
It's our responsibility.
It is.
To take care of it.
Well, thank you so much for sharing your knowledge with us today.
My pleasure.
This has been an incredible journey through the atmosphere.
It has.
And I think we've all learned a lot
I hope so.
about how this invisible force field shapes our world and how we can all play a part in protecting it.
That's the key takeaway.
It is. So to all our listeners out there,
Yes.
think about the atmosphere.
Yeah.
Think about all the amazing things it does.
It's pretty amazing.
And think about what you can do to help keep it healthy.
It's up to all of us.
Thanks for joining us on this deep dive into Earth's atmosphere.
Thanks for having me.
Until next time, keep exploring and keep looking up.